Hello students. So we'll be talking about one more numerical of Porter governor. So let's read out the numerical. Each arm of a Porter governor is 250 long and is pivoted on the axis of the governor. So we have four arms of the Porter governor we know, and all the lengths of each of them is 250 given. The radii of rotation of the balls at the minimum and maximum speeds are 150 and 180 So this is also, you know, that when the speed is minimum, then its radius of rotation of the balls, that means this one, this one, where is it? When this is the radius of rotation, right? So this one, so this is 150 when it is speed is minimum, and when the speed is maximum, obviously the balls will move apart. So like here, okay, so the radius will be increasing, so that is 180. So the minimum radius is 150 and maximum radius is 180. Okay, that is given. So we have drawn it here actually. 250 of these are the lengths of each arm. 150 is the minimum radius, 180 is the maximum radius. So these will remain 250 again. Okay. So now this is mz and this is capital Mz by 2. If we have friction, then we'll have plus minus f here. Okay. So this is h, the governor height, and this is a. Okay, and this much is b. We know. Now the thing is, we'll see that further conditions given in the question. Let's see. The mass of the sleeve is 28 kg. That is capital M given, and each ball is of 5 kg. So small m is given. Find the range of speed of governor. Also determine the range of speed if the friction of at the slip is 18 Newton. So here there is nothing given about the friction. That means we can neglect the friction, and later when friction is at friction value is 18 degree, sorry 18 Newton, you have to find out the range of speed. That means what will be the maximum speed, what is the minimum speed. Okay, get your difference between them. So here without the friction, you have to find out the range of speed, and here with the friction, you have to find out the range of speed. Now the thing is here, unlike the previous question where we have seen that the uh, lower arm is at distance away from the center line, here nothing is given like that. So we can connect the lower arm also to the center line. Okay, like this. Upper arm is here, lower arm is here. Okay, it's connected like that. So 250 to 50 both. So in this case, one thing is clear, that this line, okay, if you extend, and this line if you extend, this angle and this angle both are same. Okay, why? Because you see this is 150, right? This is 250, this 250, this is 150. So these two are similar triangles, this one and this one, both are similar triangles. So they will have, so we have taken this triangle here actually here. This one is the triangle, and this is the triangle. So since both are similar triangles, they are angles, opposite angles that is touching each other. These two angles, this angle and this angle, these are same. So in both cases, in 150 also, in 180 also, this angle theta and this angle beta, theta and beta, theta and beta are these angles. You can see here. This is theta, this is beta. These two angles are same. So if that is the case, then what happens? If beta and theta are same, see 10 beta is equal to 10 theta, then k is 1, small k is 1. Okay, and for first case we have taken friction as 0 because it is not given. So this is the case we have to consider, k equal to 1 and f equal to 0. So we'll consider this formula to solve. Okay, so we are given with n, value of n already. So n is actually, sorry, n is not given. We have to calculate n. We have to find out at a sleeve radius 150 and 180 both. So let's go through the problem. So a small m is given, capital M is given, f friction is given as 18 Newton. Okay, so now you have drawn these two figures. Yes, so you have you know that k is 1 and friction force is 0. So what you need here is you need the h value. Okay, because you can see in the formula that 895 by h is required, right? So just get h in both cases and you can solve the problem. So how to get this h? Using trigonometry, simple thing. 250 is known, 150 here is known. What will be h? H will be, yes, h will be actually, you can uh, 250 square minus 150 square root of that. So this is root of 250 square minus 150 square. So h is 200. Just put the value of h here, 200 mm, huh? So this has to be in meter because this g is in meter per second square. Okay, that's 9.8. Now, by the way, you can cancel g here, m plus m by 2 m, but still you convert this into SI units. So so that you can get this RPM, meter revolution per minute. So actually you'll get n square is equal to this 295, and take the square root of this, you'll get 171.85 RPM. So this is the first case when your speed is minimum. When your speed is minimum, this distance is 150. And when your speed is maximum, this distance is 180 because the balls will move farther apart. Yes. So just in case of 180, what will be the value of h that you find? How will you find? Root over 250 square minus 180 square. So that is 250 square minus 180 square. This is h. So put the value of h. Okay. 0.173, whatever. Then you get n. So this is the maximum speed. So you know the minimum speed and maximum speed now. The range of the speed is actually the difference between maximum minus minimum. So you have got the range. Fine. Done. Next, you are given with the friction. Okay. So when friction is there, see k is 1, k is 1, k is 1, and friction is not 0. So this is the condition now. Okay. So to use this equation. So you have to when to use plus, when to use minus. That is important. So you can see that in this Porter governor, what happens when the balls move apart? This will go up, right? So when it goes up, see its force mg, m in capital Mg, the weight is downwards. When it moves upward, the frictional force is also downward. Okay, because frictional force is opposite to the movement. So mg plus f. See when this will happen, when this is at maximum speed. When speed is maximum, the balls is farthest. So this part is moving up. Okay, so when this is moving up or when the speed is maximum, then we will have to take this as plus mg plus f. And when the speed is minimum, ball is coming closer to each other, then this sleeve is moving down. So when the sleeve is moving down, the frictional force is upwards. That means mg and f both are opposite. So in that case, mg minus f will take. So simple thing, when the maximum speed is there, when speed is maximum, then they will be plus. So this you have to see. Here you can see at maximum speed. So mg plus f we take. And at minimum speed, mg minus f we take. Okay. Because of the friction. At minimum speed, ball is coming closer to each other. Sleeve is going down. That's why friction is upward. That's why mg and f both are opposite in direction. That's why we have taken this as negative. And in case of maximum speed, this is positive. That is the only change. H now, you can ask me, at minimum speed, which one is minimum speed? This one, isn't it? 171 as compared to 186, this is minimum. And at minimum speed, what is the value of H here? 200. Okay, so use 171.85 and 200. When n is 171, H is 200. And when n speed is 186, then H is 173. Okay, you see, because it was reduced. Actually, that is the case. So here you can see that you have put at minimum speed, means minimum speed is, what is the minimum speed? 171. H is what? 0.2. So put 0.2 here, 0.2. Okay. So and at maximum speed, H is equal to 1.17. So put 0.17. Understood? M and G are known. M is given, capital M is given. Force friction force is 18 given. This is 895 is standard value. So you have got the speeds now. 167 with friction. These are with friction, and this is 189 maximum speed, and this is minimum speed. And the range will be their difference. So the range is not found, but you have to take find their difference. This minus this. That will be the range. Okay. So this completes a numerical of Porter governor. We'll continue the class in the with Hartnell governor next. Thank you.